Friday, if you, for some reason you were not here Friday, I know there's some people out, obviously, besides the seniors. If you were not here Friday, they did the warm-up for 9-4. That is the first part of your quiz, and it covers the 3 topics. So there was 3 different topics in 9-4, which is your parametric. One was graphing using the T-chart. One is eliminating the parameter where you solve for T and then plug it in to get rid of it, and you get one equation as an answer. And the third is the reverse of that. You're creating the parameter. So one equation was that had a T and the other one didn't. You solved for the one that did have the T, plugged it into the second, so your answer there was both equations. Those are the 3 types of questions from parametric. Polar is completely different. Polar is, so 9-5, we're going to learn about polar coordinates, like specific coordinate points, like just a point on a polar grid. You're going to learn about a polar grid. And then 9-6, we're going to start to graph equations of these. I think 9-5 is easy, but obviously it's brand new. So if you're the type that's sitting there that like kind of shuts me out, it's not going to be easy. If you pay attention and you review these 2 sections tomorrow with me, Wednesday's quiz should be easy. It's not tricky. It's not complicated. It's pretty straightforward, but it is all brand new stuff. So this is stuff, obviously, you have to make sure you're reviewing. So a polar coordinate system has 2 parts to it. It has an X and Y axis that look just like we're used to, except they have new terms. The X axis is now called a polar axis. And they will look like coordinate points, but they have 2 parts to them. A directed distance or a radius, because R could be either, and a directed angle. So these coordinate points, and you're going to see it in a second, but they're going to have, it looks almost like an X and Y. It's a this, comma, this, and it's R, comma, theta. R is your radius or the distance from the pole. So center is now called the pole. And then theta is the angle in which you go out from. These will be unit circle-based angles. So we go back to making sure you know unit circle. In this section, you're going to need to know thetas. Yes, it doesn't go away. I've warned you from the beginning of the school year. We're going to need to know our thetas, and then we're also going to need to know the sine and cosine at those. You'll see that in a little bit.
So the R is the pole?
R is the distance from the pole. So like a radius. Like if it's 1, it's 1 unit out. You're going to see there's going to be these like circles on your polar graph. And that every ring is 1.
And what's the theta?
Theta is the angle in which you go from.
So we should just think of it as a radius?
Yes. Yeah. So each point in the plane can be assigned a polar coordinate, which is r theta. And r, like I said, it's the directed distance from O to P, O being the pole and P being the end point. But this is also just your radius. The difference is that you can't, like the radius is not part of your point. It tells you where to put the point, but you don't want a line. You want a coordinate point. And then again, theta is the angle. You go counterclockwise from the pole to the segment just like you would normally do as though you were moving around your unit circle. So if theta is pi over 3, I go to where pi over 3 is. This would be like pi over 3. And then I go out however far r is. Again, you're going to see this in a second. It's rings, like circles, almost like a dartboard. And you move out that many sections.
You said the x-axis would be the polar axis.
That's the name of it.
Okay. Is there then no like parallel term for y-axis?
No. It's just the polar axis. Yeah, that gets changed.
You go clockwise from there.
You go counterclockwise, like you do your normal unit circle. Yep. Okay, so you're going to go to the web and you're going to find a polar coordinate grid, okay? So if you go to Safari and you search for polar coordinate grid, I feel like at some point I posted it on one of the. Your goal is to get something that looks like this, okay? Oops. It doesn't have to have 7 rings. This one has 7 rings. It doesn't matter how many rings it has. Your goal would be to have, at minimum, your unit circle angles. So sometimes they divide even further, like they give you more than that. It also has all your unit circle angles. So it starts at 0, goes to pi over 6, pi over 4, pi over 3, pi over 2, all the way around, okay? So all the over 2s, all the over 6s, all the over 4s, all the over 3s, and then your quadrant angles like 0 and pi are on here, okay? So if you look at your, like if I just look at A, it says plot the point 2 pi over 3. Instead of starting with the 2, I start with the pi over 3. So you want to locate where pi over 3 is, and pi over 3 is this angle here, okay? And then you go out to the radius of 2 and you plot a point. It is a coordinate point, just a point, not a line. So this would be 2 pi over 3.
So you go 1, 2.
You go to, well, because it's 2 pi over 3, I go to the second ring.
We go by, like, since it's in the x, but we should do 2 this way.
Nope. You go to the angle first, and then you go out to the second ring along that angle. Yeah. 3 negative pi over 6. Now it's negative pi over 6. So how do I find negative pi over 6? And there's 2 answers here. What's one way? Say. I can go down, right? Because negative means go clockwise instead of counterclockwise. And it's pi over 6, so that'd be the first pi over 6 you hit, which would be here. Or I go to where it's positive pi over 6 and I fold it in half along the x-axis and where it overlaps, which again is that 11 pi over 6. That would be negative pi over 6. And now my radius is 3, so I go to the third ring, and that would be 3 pi over 6.
Wait, I thought it was 5 pi over 6.
No, it's 11 pi over 6.
Because the x is negative.
Because the theta is negative.
Okay, and why? Wait, I don't understand. How do we know where to plot the point?
On the angle or on the ring?
On the ring.
So you go to the third ring. So this is 1 ring, this is 2 rings, this is 3 rings. Yep. Yep. Well, I'm going to show you that in a second.
Wait, so the reason you put it at 11 pi over 6 is because
Negative pi over 6 is 11 pi over 6. Those are the same thing.
right. So what would 7 pi over 6?
That's my bad.
7 pi over 6 would be over here.
I know, but is it a positive pi over 6 or negative?
7 pi over 6 is positive 7 pi over 6, but that is the same thing as negative 5 pi over 6. Those would be the same thing. Yep.
So the negative of 5 pi over 6 is just folded over it.
Yep. It would be 11. It would be 7 pi over 6. Yeah. Okay, you do A, and then I'm going to do B with you. All right, so 11 pi over 6 is the angle in that fourth quadrant. 3 means go out to the third ring, and that would be 311 pi over 6. Raise your hand if you got it right. Okay, good. All right, so now notice the difference on B. B actually says 3 is negative. The radius is negative. So if you have a negative R, you move away from the angle. So you move in the opposite direction. So I would find 11 pi over 6. It's still the same angle. But instead of moving towards it, like I would the 3, I actually move the other direction on the same ray. So I need it to be the same line. And move in the other direction. And that's how I would plot a negative radius. So you move the opposite direction. You start at the pole, but instead of moving towards your angle, you move away from it. So a negative radius, you move away from the theta.Moving.
Still be 11 pi over 6, right?
So you'd start 11 pi over 6, but instead of going there, you're going to move opposite it, which is 5 pi over 6.
Okay.
Yep.
Is that the same as 3, 5 pi over 6?
Yep. So these points are going to have multiple names, which is actually what you're going to get to next.
So if we put it as 3, 5 pi over 6, it would be the same answer?
Yep. All right, which is this. Good segue, Vicky. So finding additional points, okay? So you can give the same point multiple names. You can take our theta and find an infinite amount of ways to restate that. There are 2 ways to do it. One is the wording on this to me is confusing. The first thing you do is keep R the same, so I don't change R. Notice it doesn't change. And for theta, I find coterminals. So I add and subtract 2 pi, right? A coterminal angle means go all the way around your circle one more time or one last time. So to find those, you add and subtract 2 pi. So you can either keep r as the value it is and then add and subtract 2 pi to theta, and that would give you an additional point in the same spot. Or you change the sign on r, so I make r the opposite sign. If it started positive, I make it negative. If it started negative, I make it positive. And then this really just means add and subtract multiples of pi. So that 2n plus 1 just really means a multiple of pi. So instead of adding 2 pi, I add and subtract pi. Yep.
Can we pick which one we use?
And sometimes you're going to have to use both. And you'll see it. So again, if I had, like let's say I had 3 and I had pi over 3 and I wanted to find additional angles, I can keep 3 the same and I take pi over 3 and I'd add 2 pi to it, or I take pi over 3 and I subtract 2 pi from it, which you then actually find the like denominator and then figure out what it is. Or you can make 3 negative 3, take pi over 3, add pi to it, or take 3, make it negative 3, and then do pi over 3 minus pi. So if you are keeping r the same, you're adding and subtracting even multiples of pi, like 2 pi or 4 pi or 6 pi. And if you are changing r to be negative or changing the sign, then you are adding and subtracting odd multiples of pi, like 1, 3, 5, 7.
You're always gonna, like when you change the first to a negative, the first column.
Yeah.
You're always adding pi to
The angle. So you're always changing the value of the angle for the radius. You're just changing it to be positive or negative. Yeah. Okay, so instructions will say something like this. Plot the coordinate point and then find 3 additional polar representations of this point. So I'm going to plot my point first. 3 negative pi over 4. Where's negative pi over 4? Negative 3 pi over 4.
It's the same as 5 pi.
Good. It's the same as 5 pi over 4. 3 is positive, so I go 1, 2, 3, and that would be my coordinate point. So 2 ways to do it. Remember, you have to move 3/4 is bigger than a half. So I move this direction. It's bigger than a half, but less than 1. Or find it where it's positive, which is here, and then fold it along your x-axis, and where it overlaps is your negative. So you don't know it, but you already found one additional polar representation because I've already found that 5 pi over 4 as my other angle. Okay, so that's one way to do it. The other way is do what we just did. Take 3, leave it alone, so it'd be 3, and then take negative pi over 4 and add 2 pi to it. Negative 3 pi over 4. So this becomes 8 pi over 4. And this is 5 pi over 4. So that's another way of writing the same coordinate point. If you look at it, if we went to 5 pi over 4, which is then where we were, and we go out to 3, it's the same point.
That's if you want to do the other one for pi.
The other one for pi.
Like the other same point for pi. Like you're adjusting the pi. You're adding.
You're always adjusting the theta. Yeah.
Oh, you never do it to like the 3 or.
You either leave r alone and change theta by adding and subtracting 2 pi, or you change r, but you still have to add and subtract. You're always changing theta.
Okay.
Yeah, it just depends on what you're changing it by. So, but notice that this said I want 3 other representations from negative pi over 2 to positive pi over 2. So is 5 pi over 4 in that range? Yes, so I know I can keep that one. Now the other way to do it is keep r the same, but take the negative 3 pi over 4 and subtract 2 pi from it. If I make that 8 pi over 4, I end up with negative 11 pi over 4. Is that in between negative 2 pi and positive 2 pi? No, that would be negative 2 3/4 pi. That is too small, so I can't keep it. It's still at the same point, but it's not within the negative 2 pi and positive 2 pi. So now I have to go to the other approach, which is change r. It goes from positive to negative, and then take my negative 3 pi over 4 and add what to it? Pi. So this becomes 4 pi over 4, and that's pi over 4. Is pi over 4 in between negative 2 pi and positive 2 pi? Yes, so that's my second answer. So here's my first one. Here's my second one if it could give me 2 seconds. And then the other thing you can do is change our, so it would be negative, and take the original one, the negative 3 pi over 4, and subtract pi from it, which becomes 4 pi over 4. And this is negative 7 pi over 4. Is that in between negative 2 pi and positive 2 pi?
Yes.
Yes, so I get to keep that one. So while there are many answers that are polar representations of the same point, these are the only 3 that would fall between negative 2 pi and positive 2 pi. Yep.
So if you're changing the theta, you would,
You're always changing the theta.
okay, but you can either do plus 2 pi.
So you keep R the same, you add and subtract 2 pi. You change R, you add and subtract pi.
Okay.
Yep. Just to give it a like denominator. Is that what you mean? Like, why do we make it 8 pi over 4? Yeah. That 2n plus 1 is just saying pi. It's odd multiples of pi. So 2n plus 1 is an odd multiple of pi. That's all it is. So we add and subtract pi, or we could have added and subtract 3 pi, but it's going to be too big for this range. For this, it's just pi. Yep, add and subtract pi, add and subtract 2 pi. Vanessa. Because negative 11 pi over 4 is negative 2 and 3/4 pi. That's too small. My range is from negative 2 to positive 2 pi. So if you had the time to check, you could actually plot all 3 of those points and make sure that they all fall in the same spot.
So would you have 3 answers? Like those would be
Yep.
answers?
Yep. And so if I wanted to check them, this first one was 5 pi over 4. So I go to 5 pi over 4, I go to 3. That's the same point. This second one would be pi over 4, negative 3. So pi over 4 is here, but negative 3 says move in the other direction, same spot. Then negative 3 and negative 7 pi over 4, negative 7 pi over 4, so this is positive 7 pi over 4. Negative 7 pi over 4 is the same as pi over 4, and negative 3 moves, again, move away from it, and you get the same spot. So you should be able to plot each of those points at the exact same spot.
Negative 7 over 4 would be
Pi over 4.
pi over 4.
Yep.
I mean,
Yeah. And then negative 3 says move away from it, so you're in the same spot. All right. Now we're going to learn how to convert from, so rectangular is our normal XY, polar is what we're currently using. So to establish the relationship between polar and rectangular coordinates, you let the polar axis coincide with the positive x-axis and the pole with the origin. So remember, like I said before, the polar axis is the same thing as the x-axis. Y doesn't change. And the pole is the same as the origin. So if we physically overlapped these two on top of each other, that means that we can interchange coordinate points. So I can take something that says r theta and I can actually give it a value like an xy. The way you do that is there's 3 parts to it, okay? One part is you have to find theta. So to find theta, we use this first one. You can use any of these, but you don't need to find r first. So you just use the first one. Tangent of theta is y over x. So when I get given, there's 2 ways to do this. This is to go from rectangular to polar, okay? If you are given y and x, that means you're given your original rectangular coordinate point, you can find theta by doing tan of theta equals y over x, and then the next step would be tan negative 1, whatever you get from y over x. And then you use your unit circle to figure out your theta. The second part is to find r, and because r squared equals x squared plus y squared, r is going to equal the square root of x squared plus y squared. So that's this side of this little chart on the bottom, okay? Kind of shortens it. I would say that chart on the bottom is the easiest way to see it. So to go from rectangular to polar, you have to find 2 parts, theta and r. Tangent of theta is y over x. And then we tan -1 it, so you look on your unit circle for where tangent equals the value you get. And then r squared equals x squared plus y squared, so I square root x squared plus y squared, and you get the r. The other direction is polar to rectangular. So if I start in polar with your r theta, you do x equals r times the cosine of theta and y equals r times the sine of theta. Theta would be unit circle base, so you would then figure out your cosine and your sine from your x and y coordinates, and then you multiply it out.
What is rectangular?
Like x, y, like 2, 3. That's rectangular.
Polar is below the unit circle.
2, 3 pi. That would be polar.
The rectangle is just a regular coordinate.
Yep, your x, y that you already know. All right, so because they can look the same, if I had 2, 0, right, and I asked you to tell me if that's rectangular and polar, how would you know? Is there a 0 radians? Yes. Is there a 0 y coordinate? So you wouldn't know, which is why you have to label these. So you'll see your answers written as r comma theta equals or x, y equals. You've got to make sure that you include those when you give the answers, okay? On WebAssign, it's going to give it to you already. But obviously on a quiz or test, it's not going to. So you want to make sure if your answer is supposed to be rectangular, you write x comma y and then your answer. If your answer is supposed to be in polar, then it's r comma theta equals your answer. So we'll do it every time we do an example.
Do you want that for all of them?
Yep.
Or just the ones that can go for
Just the conversion ones. The other ones you don't have to convert, so there won't be 2 forms. So the ones we already did, you don't have to because that's only 1 form. All right, so A says convert the point 2 pi to rectangular coordinates. So I am going from polar to rectangular, which means my answer is going to be x comma y equals, and then I'm going to get a coordinate point. So to go from polar to rectangular, x equals r times the cosine of theta, and y equals r times the sine of theta. That was on the last slide, and hopefully that makes sense because we know cosine is the x and we know sine is the y, right? So our r is what? 2, and theta is pi. So I'm doing 2 cosine theta and I'm doing 2 sine theta, which is pi. Pi is where on my unit circle? On the left. What's the coordinate point there? -1, 0. So what's the cosine?
Wait, I'm confused. Where did you get -1, 0?
That's the coordinate point at pi.
I thought it was 1.
No, move left, right? Pi's on the left. I'm not lying to you, right? Pi's on the left, right? Evens are on the right. So 0, 2 pi, 4 pi, that would be on the right. Pi is on the left. So the cosine there is -1. So this is -2. And the sine there is what? 0. So this would be 0. So the coordinate point would be -2, 0. Now, if I had plotted this on a polar coordinate grid, so go back to your original angle. And if I had plotted 2 theta, 2 pi, sorry, pi is there. 2 would say move towards there, put a dot on the second ring. Now, if I had overlapped this with an x and y axis, this would be left 2 spots, which would be -2, 0. So they should overlap. Like if you're unsure about did you get to the right answer, if you could visualize your x and y axis on top of your polar axis, they should overlap. If they're an actual quadrant angle, so if it's 0, pi over 2 pi, or 3 pi over 2, or 2 pi, they should be exact. The ones that are floating in between are going to be a little bit off because we're approximating. But the coordinates that are on your quadrant angles, those should be exact. All right, so then B, again, converting This would be in polar. I'm going to rectangular. So my answer is going to be an XY combination. X equals R cosine theta and Y equals R sine theta. R is what? Root 3. Theta is pi over 6. So then it's root 3 sine pi over 6. What's my coordinate at over 6? Root 3 over 2 and 1/2.
Are we on this? Oh, yes.
Uh-uh.
You don't have to fill it out like the day before.
No, you have a quiz. You have tons of time. What's the X on here? So what's the cosine? Square root 3 over 2. What's root 3 times root 3? 3. So this is 3 over 2. And then the sine at pi over 6? 1/2. So this is root 3 over 2. And then that's my coordinate point. You can either write it as 3 over 2 or 1/2. It doesn't matter. But then the root 3 over 2 is going to keep exact. So again, if I was to plot that, like if I was to plot it polar, pi over 6 is here. I'd go to the third ring. I'd plot my point. And then 3 over 2 is 1 and 1/2. And then root 3, you'd have to approximate. That's like a 1 point. I'm going to make it 8 so it's even. This is like a 0.9 because it would be 1.8 divided by 2. So if I went to the right 1.5 and I went up, it should be about the same place. So it's hard to see it, obviously. Yep.
Wait, so we're not gonna get any of this with quiz?
You mean the unit circle?
Yeah.
No.
Or
You-
the
Your polar coordinate grid will be blank on your quiz. So you could kind of use that as your guide. Like the angles are going to be marked. So you could use that as the angle part, but you need to know the coordinate points at those.
oh, so the angles will be there.
Right, like this blank is going to be on your quiz because you have to graph on it. Does that make sense?
Yeah.
So the angles will be there.
But like 7 pi over 6.
Actually, are your angles on there? I'm starting to think they're not anymore. No.
I don't know what 5 pi over 2.
Oh my gosh, if you don't know the unit circle at this point, y'all,
I don't. I know what
you have till Wednesday.
need something to.
We-
I'd rather see.
All right, now we're going the other way. Now it says convert the point to polar. So I'm going from rectangular to polar. There are 2 parts to it. I have to find theta and I have to find r. So this was on that first slide, but r squared equals a squared plus b squared. So I go to the next step and I say r equals the square root of a squared plus b squared. That's how I'm going to find r. And then tangent of theta equals y over x, and I'm going to end up negative 1ing that because I need to actually know the angle.
Wait, so we're gonna have a calculator?
No,
Wait, I thought we were gonna make calculators because of the other one.
no.
So how do we find the angle?
There, that's it. That's a point that's on your unit circle.
But we don't know the answer.
Well, sounds like a personal problem. All right, so r, this is your, this could be x or y, sorry, x, y. This is your x and this is your y. So r equals the square root of 2 squared plus 2 squared.
Wait, is that supposed to be an answer?
Yeah, a and b is same as x and y. This is x, y, same thing. So this is the square root of 4 plus 4, square root of 8, which ends up being 2 root 2. That's the r. And then tan of theta equals, what's the y? 2. What's the x? 2. So tan of theta equals 1. So I have to figure out what angle by saying tan negative 1 of 1. You're saying what angle on your unit circle has a tangent of 1. There are 2 answers actually. One is pi over 4 and one is what? Where else is tan positive? Third quadrant, sorry, third quadrant. And what's the over 4 in the third quadrant? 5 pi over 4. Okay. There is only one of those answers that is right, though. How do you think you could figure it out? No. Where would 2 be? In the first quadrant. So I picked the first quadrant angle.
Wait, I'm confused. How did you know it's 5 times?
Because it's an over 4 because it's 1, right? And then tangent is positive at the over 4 in the first quadrant and the over 4 in the third quadrant. There's a comma button. We're going there next. Yeah. Okay, so then B. Same thing. R equals the square root of -1 squared plus 0 squared. Square root of 1, which is 1. So that's my radius. And then tan of theta equals 0 over -1. And 0 divided by -1 is what? Tan is y over x. This is 0. So where on your unit circle is tangent 0?
Oh, this one.
At 0 and at pi. How do I know which one to pick?
Because, wait, it's that one.
Yep, because where would -1, 0 be? Over here. Yeah. Say again? No, so 2 pi is not, we don't include 2 pi. It's from 0 to 2 pi, but there's a parentheses on the 2 pi, it doesn't include it. This was not on your quiz. It obviously will probably be included on your test, but this is not on your quiz. You're not getting a calculator on your quiz. So in order to convert from from polar to rectangular or rectangular to polar, using your graphing utility, you now have to switch your mode again. So we switched our modes to parametric. Now you got to be in polar and you got to be in radians. All right, so here, first thing is it's got to be in polar and in radians. So we're going to go mode. I'm going to go down to where it says radians. Obviously, that has to be selected. And then I'm also going, has to be radians, it has to be polar. So in that next line in which we have it on parametric, you're going to arrow over to polar. And you're going to hit enter. So it has to be rectangular. It has to be radians and polar. Okay, that's the first part. So if you look at the directions, it says convert the polar to 2.5, 1.58 to rectangular. So this is in polar, which means this is my R and this is my theta. And I'm going to rectangular. Okay. There is actually, oh man, is it here? I forget where it is. I'll show you 2 ways to do it. One is all calculators can do what we've already done. To go from rectangular to polar, I would say that x equals r cosine theta and y equals r sine theta. So I would do 2.5 times the cosine of 1.58, and then I would do 2.5 times the sine of 1.58. This is super hard. This gives you -0.023, and then 2.5 sine 1.58 gives you 2.4998, so this would end up being 2.50. And this we would rewrite as x comma y equals. All right, so now we're going rectangular to polar. So r equals the square root of 6 squared plus 9 squared, and tan theta equals 9 over 6. So square root of, and you're just going to do let the calculator do all the work. 6 squared plus 9 squared, and I get r equals 10.82 if I round to 2 decimal places. And then I'm going to do tan -1 of 9 over 6. You don't even need to reduce it because the calculator will do it. And I get theta is 0.982. So that's theta. So when I write it as r theta, it would be 10.82, comma, 0.98. So those can be done on any scientific calculator. If you have the I think it's the 84 and the 83. I think they have the same menu, but I'm going to show you a little bit of a shortcut. So there is a button under the angle menu. If you go second, apps, and you go to that angle menu, there is 5, 6, 7, and 8. You see 5 says R to PR and R to P theta. And then 7 says P to RX and P to RY. So R to PR means rectangular to polar, and it's going to give you the R. So I'm going to do that first, rectangular to polar. So I'm doing B. And for this, you literally type in 6, 9 both times. 6, comma, which everybody was like, your calculator is a comma? It does, it's there. 9, hit enter, and there's your 10.82. And then I do the same thing, second, apps, go back to the angle menu, and now I'm doing rectangular to polar theta. And I do 6, comma 9 again, and there's the theta, 0.98. The comma is right above the 7. Good. And then I'll do A. So now we're going to do polar to rectangular. So I go second, apps, back to that angle menu, polar to rectangular. This one's going to give me the X, 2.5, comma, 1.58. There's the X, negative 0.023. And then second, angle, polar to rectangular Y, 2.5, comma, 1.58. And there's the 2.499, which rounds to 2.5. So just be really careful. Obviously, that whole thing gets messed up if you're in the wrong mode. Polar doesn't matter when we do the original kind and not the shortcut. It has to be in radians. But then when you're going to use those shortcut buttons, it has to be in polar and radians. Homework, that's on just 9.5 tonight, and then tomorrow we'll do the 9.5 warm-up. I will review the unit circle building again at the request of the other class, and then you will do your quiz review, and then quiz Wednesday.